Welcome to this explainer on the Claude Master Memory Tool API. We're diving straight into a brand new advanced beta feature that tackles, well, honestly, one of the most maddening bottlenecks we all face in AI development right now: context amnesia. Today, we're going to fix your agent's memory. Think about it for a second. What actually happens when your coding agent completely forgets that critical bug fix you worked on together just yesterday? The painful reality is that the default behavior of large language models is, of course, completely stateless. Every single session starts totally from zero. Now, for a simple chatbot, sure, that's fine. But when you're building a complex support system or a coding assistant that really needs to accumulate knowledge over time, starting from scratch every time just shatters your entire workflow. Enter the Claude Memory Tool. This API feature is a massive shift because it finally gives Claude persistent storage across totally separate conversations. It's best to think of it kind of like a virtual file system. Claude can literally autonomously issue structured commands, things like create, view, update, delete, and rename, and it targets files within a specific memories directory. To really grasp why this is such a game changer, I want you to consider this number: 84%. In a highly rigorous 100-turn web search evaluation, combining this memory tool with context editing reduced token consumption by a staggering 84%. That's compared to blindly loading the full conversation history every single time. It's a massive savings. But hey, it's not just about saving tokens, right? Using this memory tool also led to a 39% improvement in task completion over the baseline. That's not just some marginal efficiency tweak. We're talking about the literal difference between an AI workflow that actually works in production and one that just absolutely fails. Let's ground this with a real-world scenario. Let's say you have an AI customer support agent. A user reports a totally obscure error, and the agent spends time diagnosing a really tricky version 2.3.1 JSON Web Token expiration bug. With this tool, before logging off, Claude writes that bug and the exact solution directly to memory. So, days later, when a completely different customer hits that exact same error, Claude instantly reads that memory file, recognizes the match, and resolves the ticket in seconds. Bam! No repetitive diagnostic work. So, architecturally, how does this work? Well, there's a really clear division of labor here. On one side of the equation, Claude uses the API to issue structured tool calls. But, and this is the absolutely crucial part, your application sits on the other side. Your app actually receives those commands and handles the real execution against whatever storage infrastructure you prefer. That could be a local disk, a database, or even your own encrypted cloud storage. And because you own that storage layer, Anthropic never actually sees those memory files. Period. By design, this architecture natively supports zero data retention compliance. For those of you working on enterprise deployments where strict data privacy and security are just non-negotiable, this is a huge, huge advantage.
Now, you might be sitting there wondering, okay, when do I use this versus my other context methods? It breaks down pretty simply. For short, single-session chats, standard message arrays are perfectly fine. If you are searching massive, gigabyte-sized external document corporations, a vector database with RAG is absolutely still your best bet. But you're going to use this memory tool specifically for structured, persistent knowledge that Claude itself generates and manages over time.
So this really is a complete paradigm shift from stateless to stateful AI. But what's the trade-off? Well, you do have to build the backend. Your implementation checklist is going to include a few key things: adding the specific beta context management header, dropping the memory tool identifier into your tools array using the SDK helper classes, and of course, writing your custom file handlers with strict size limits. Basically, the API asks for storage, and your app gets to decide exactly how to provide it. And listen, because you own that backend implementation, please pay super close attention to this critical security warning. You absolutely must always include path validation in your write handler. You have to resolve both your base memories path and the requested path to their absolute forms. Seriously, just a simple relative to check in Python will catch directory traversal attempts and stop bad actors dead in their tracks before they ever touch your storage layer. Don't skip that step. To truly master this implementation and transform your stateless bot into a genuinely persistent, learning agent, you'll want to dive into the full chapter at claudemaster.net. It's packed with 3 fully worked examples and a really solid guide on dodging those common implementation pitfalls. So, as we wrap up this explainer, I want you to think about your own projects for a second. What critical piece of knowledge will your AI agent accumulate first, now that it finally has a real memory?